And in this topic, we shall start with the introduction or definition of different terms involved. So the first term is earth, earthing, earth. Then we'll go to purposes of earthing. Then we'll go to specifications regarding earthing of electrical installations. And here we shall focus on distance of earth from the building, where actually you should have your earth pit, size of the earth continuity conductor, what size of cable you should use for your earthing, resistance of earth as per different soil, points to be earthed as per the IEE regulations or IEE rules. Then we look at earth resistance. We look at methods of reducing earth resistance of the system, and we'll also look at earth electrode and earthing lead. Again, we look at methods of earthing, including strip or wire earthing, rod earthing, pipe earthing, and plate earthing. Another thing we look at specifications for earth wire and earth plate. Again, we look at earthing systems, and this is the TT system, the TN-S system, the TN-C-S system, and lastly we'll wind up by bonding. So that is what is in our fifth topic, and I shall start with the definition of this, the term earth. I'll start with the definition of the term earth. So earth can be defined as a thin layer of material which covers our planet, be it rock, clay, chalk, or whatever. A thin layer of material that cover our planet. It can either be rock, it can be clay, it can be chalk, or etc. So that's how we define the term earth. So earthing basically means connection of the neutral point of a supply system or the non-current carrying parts of electrical apparatus, such as a metallic framework, metallic coverings of cables, earth terminal of socket outlets, stay wires, etc., to the general mass of earth in such a manner that at all times an immediate discharge of electrical energy take place without danger. And the third term, I've defined this, and the first term is earth. So earth is just very simple. So earth you can define as a effective connection to the general mass of earth. Effective connection to the general mass of earth. So let's look at the purposes of earthing. Let's look at purposes of earthing. So one is to ensure that no current carrying conductor rises to a potential with respect to the general mass of earth than its designed insulation. I say one purpose of earthing is to ensure that no current carrying conductor rises to a potential with respect to the general mass of earth than its designed insulation. The second purpose is to avoid electric shock to the human beings. The other purpose of earthing is to avoid electric shock to human beings. And number 3, to avoid the risk of fire due to earth leakage current through unwanted path to avoid risk of fire due to earth leakage current through unwanted path. Those are the main purposes of earthing. Let's look at specifications regarding earthing of electrical systems. Okay. So first of all, we look at the distance of earth from the building, and very few people always does this. So we look at the distance of earth from the building. So an earthing electrode shall not be situated within a distance of 1.5 meter from the building whose installation system is being earthed. So what does this term mean? So when a building is here, there's a building here, and you want to have your earth pit. So that earth pit should not be within a distance of 1.5 meters. It should be out of this one. So your earth pit should be here. Many occasions you find there's a meter box here, and somebody just have an earth pit that's next to the building here. So the earth pit should be 1.5 meters away from your building. So in case of any earth fault, then it can be taken away from the building. That's the main reason. Many people don't consider that fact. So distance from the earth from the building. So an earthing electrode shall not be situated within a distance of 1.5 meter from the building whose installation system is being earthed. Let's look at the size of the earth continuity conductor. So the conductor by means of which the metal body of an equipment or appliance is connected to earth is known as earth continuity conductor, the ECC. The ECC can be ensured either through metal conduit, metal sheathing of metal sheathed cables, or by a special earth continuity conductor. The cross-section of ECC should not be either less than 2.9 millimeters square, and that is 14 SWG. That is standard wire gauge. That's one for the American. Or half of the insulation conductor size. Or half of the insulation conductor size. You have to check that. Let's look at resistance of earth. Number 3, resistance of earth. So the main principle regarding earth resistance is that the earth resistance should be low enough to cause flow of current sufficient to operate the protective relays or blow fuses in the event of an earth fault. The value of earth resistance does not remain constant but changes with the weather, as it depends upon the moisture content of the soil and is a maximum during dry season. The lower the earth resistance, the better it is. So the earth wire and earth electrode will be of same material. The earth wire and the earth electrode should be the same material. You cannot use the copper rod and again use aluminum. You use a copper rod here, then you use aluminum cable to connect it to your installation. So if the copper rod is used, meaning the same copper material will be the one that will be used as earthing lead to your installation. Now the earth wire shall be taken through GI pipe of 13 millimeter diameter for at least 30 centimeter length above and below surface to the earth electrode to protect it against mechanical damage. I shall explain that. So it is not necessary that certain earth wire. It is not necessary that earth wire connected to earth electrode is run along the whole wiring system. All the wires run along the various subcircuits shall be terminated and looped firmly at the main board, and from main board the main earth shall be taken to the earth electrode. The loop earth wires used shall not either be less than 2.9 mm square, that is 14 SWG, or half of the size of the sub-circuit conductors. And lastly, the earthing electrode shall always be placed in vertical position inside the earth or pit so that it may be in contact with all the